Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2020 Process Instrumentation, Dynamics and Control Questions with Solution. GATE 2020 question paper and answer key link is available in my description box. You can download it. Question number 53. Consider the following closed loop system YSP. YSP is equal to set point. GC is equal to KC. GC is nothing but transfer function of the controller. GF is given. GF is equal to 10 by 0.1s plus 1 transfer function of the control element or final control element. GP is equal to transfer function of the process 1 divided by 0.1s plus 1 whole square. Y is equal to response or output. For a gain margin of 1.6, the design value of Kc is. We are going to calculate proportional sensitivity or gain or Kc value with the help of GC, GF and GP. After calculating the Kc or proportional sensitivity value, we have to round up the result to 1 decimal place. Solution part, closed loop system, Y is equal to response, YSP is equal to set point, GC, GF and GP transfer function of controller, final control element and process. Gain margin is equal to 1.6. So determination part, Kc or gain or proportional sensitivity. Step number 1, determine the open loop transfer function. How to calculate open loop transfer function? G of S is equal to GC, GF, GP. So we have 3 transfer function, product of these 3 that is equal to G of S or open loop transfer function. GC is equal to KC, GF is equal to 10 by 0.1s plus 1, GP is equal to 1 divided by 0.1s plus 1 whole square. Refer the diagram. Step number 2, determine the overall phase angle. Phase angle denoted as pi. Okay, this is overall phase angle. We have 3 transfer function. So summation of these 3 transfer function phase angle value, that is equal to overall phase angle. So generally phase angle formula pi is equal to, this is pi is equal to tan inverse of imaginary part divided by real part. So imaginary part means that is IP divided by real part RP. Okay. So this is general formula for phase angle and frequency response. So here phi 1 is equal to 0 degree. So pi 1 means first transfer function Kc. So the Kc phase angle value is 0 degree. So why? Because no imaginary section. So here imaginary part is equal to 0. 0 by anything that is equal to 0. Tan inverse of 0 is equal to 0 degree. So second transfer function 10 by 0.1s plus 1. This is first order. Okay. So the first order transfer function G of S is equal to tan inverse, so here 1 by tau S plus 1. So this is the first order transfer function, 1 by tau S plus 1. This is first order transfer function. So here first order phase angle pi is equal to tan inverse of minus omega tau. Okay, tan inverse of minus, this is inverse minus omega tau. Okay, yeah. This is minus omega tau. So this is the general equation of phase angle for first order system. So our second transfer function, so similar to first order system. So this is first order system transfer function. So here phase angle value tan inverse of minus omega tau. So what about the tau here? 0.1 minus 0.1 omega. Are you clear? Okay. So the third transfer function, 1 by 0.1 s plus 1 whole square. This is multi-capacity control system. Tau 1 s plus 1 into tau 2 s plus 1. So here 0.1 s plus 1 whole square. So here we have the two first order system. That's why here 2 tan inverse of first order phase angle minus omega tau minus omega tau value 0.1. Okay. So this is phase angle. Phase angle is equal to totally 3 tan inverse of minus 0.1 omega. Okay, this is the overall phase angle. So what about the pi here? The pi is the phase angle for open loop transfer function. So the open loop transfer function, the pi is equal to minus 180 degree. Okay, so take pi is equal to minus 180 degree for open loop transfer function. Substitute here minus 180 degree, that is equal to 3 tan inverse of minus 0.1 omega. So here minus 180 degree, that is equal to minus 3 tan inverse of 0.1 omega. From this calculate the omega value. This omega crossover frequency phase. Okay, phase crossover frequency. So the omega is equal to 17.32. So this is also denoted as omega C naught P. The C naught is a crossover frequency. P is denoted as a phase. Okay. So next is step number 3. Step number 3, determine the overall amplitude ratio. Amplitude ratio is denoted as AR, is right. So the overall mean we have 3 transfer function. So multiply the 3 transfer function amplitude ratio. AR1, AR2 and AR3. So for first order system, what is the formula of amplitude ratio? Amplitude ratio general formula. Amplitude ratio is equal to root of, so real part squared, that is RP. Okay, so real part squared plus imaginary part squared. Okay, RP squared plus IP squared. So this is the general formula for amplitude ratio, RP squared plus IP squared. Okay, so for first order system, what is the formula for amplitude ratio? Amplitude ratio is equal to 1 divided by root of 1 plus omega tau whole square. Okay, this is the first order system amplitude ratio, omega tau whole square. Okay, so take the first transfer function, that is Kc. AR1 is equal to Kc. So here no imaginary part is right, so only real part. So the Kc squared, the root of Kc squared means that is equal to Kc. Amplitude ratio is equal to Kc. This is the first transfer function, that is AR1. So what about the AR2? AR2 is the second transfer function, 10 by 0.1 s plus 1 is right, that is the second transfer function. Refer the diagram. So here 10 is a numerator part, don't worry about the numerator, you take the numerator value 10 divided by root of 1 plus omega tau whole square. What about the tau value? Tau is a 0.1. Why? Because g of s is equal to 1 by tau s plus 1. So here 10 by 0.1 s plus 1, tau is equal to 0.1. So 1 plus 0.1 omega whole square. So this is root. Okay, this is the formula for first order system. So here we have two transfer function is right. So here multiplication. So 0.1 s plus 1 whole square, that is a third transfer function. So we have the two first order system. So for one first order system, 1 by root of 1 plus omega tau whole squared. Another first order mean 1 divided by root of 1 plus omega tau whole squared. So root into root, that is cancel the 1 plus omega tau whole square. So here 1 plus 0.1 omega whole square. Are you clear? Okay. So from this we are going to find out the amplitude ratio. How to calculate the overall amplitude ratio here? So we have omega value. Substitute in this equation. Find out the amplitude ratio overall value. So here amplitude ratio is equal to 1.259 kc. Okay, this is the third step. Fourth step, gain margin is equal to 1 by amplitude ratio. Amplitude ratio is equal to 1.259 kc. Substitute here. From these find out the kc value. Kc is equal to 0.49. Okay, so this is the answer for this problem. The kc value or proportion sensitivity or gain value 0.49. Okay, so the range of this problem kc value 0.49 to 0.51. Okay, thank you. For further related videos, you can like, share and subscribe my channel.